more than a symbol. This was actually of our own creation.
It is really true that you can only explore the solar system for the first time once. Voyager did that.
How could one be so lucky? It's a dream, and it came true.
50 years from now, Voyager will be the science project of the 20th century. The mission, the big mission.
We didn't imagine big enough. It opened our eyes to worlds, to real worlds.
Üdvözletet küldünk magyar nyelven minden békét szerető lénynek a világegyetemen.
It was an unworldly experience. To fly through that small little window of space and time, it was absolutely astonishing that we were able to pull that off.
太空朋友，您好，您吃饱未？有闲就来阮家坐哦。
Oh, come on.
We created an artificially intelligent spacecraft that we hurled into space. This may, in the long run, be the only evidence that we ever existed. You know, when you know that about something you're working on, you treat it with great respect.
It's taking what you thought you knew and having it just spun around, and you're in one universe one moment, you're in a completely different universe the next.
I'm wishing on a star to follow where you are. I'm wishing on a dream to follow what it means. And I wish on all the rainbows that I've seen.
When it was just recently announced that Voyager 1 was in interstellar space, it was like humanity had just become an interstellar species. It was like knocking on eternity's door.
Voyager's on the other side of the solar system, and it's billions and billions of miles from the nearest other human-made object.
A time when you would be. Just think about the distance that Voyager's gone and the years that it's traveled to get there, and it's still going. So far away from me.
Voyager made it, accomplished something no one dreamed it could do.
Every second, it goes to another place where we have never been before.
It's on an escape trajectory. It's not coming back. It's just going to keep going forever and ever out into empty, empty space.
Voyager takes the cake. It's the most audacious mission. I mean, who'd have thought that we'd actually be able to do that in 1977?
I'm wishing on a star.
We knew a little, because you can't observe from the Earth with telescopes.
It was big. No, let's see, what did we know? We knew they were all gas giants, mostly made up of hydrogen and helium and some methane on the outer planets.
We knew that there were winds on Jupiter. We knew about the Great Red Spot on Jupiter. We knew that there was trapped radiation, so we knew there was a magnetic field.
We knew, for example, at Jupiter that there were 4 moons, Io, Europa, Ganymede, and Callisto, going around. That's what convinced Galileo that Copernicus was right and that the sun is the center of the solar system.
Satellites of the outer planets, we knew that they were there because we could see them orbiting, but I think everyone figured they would be just battered ice balls, kind of like the highlands of the moon, nothing but impact craters. That view was so pervasive that they didn't even think to add any geologists to the Voyager mission.
For Saturn, we knew about the rings and we knew about the major satellites, but hardly anything more than that. And it was all very fuzzy. Nobody had ever been to the outer planets to speak of. Pioneer had gone past Jupiter and Saturn, but didn't have it had an elementary camera. It didn't really show very many images, and the instrumentation was not very advanced.
The Pioneer spacecraft were mostly, let's see, can we send something through the asteroid belt? Would it survive? There were so many things that we take for granted now we knew nothing about. And the same was true for Uranus and Neptune. They're very far away.
I had been staring at these planets through some of the best telescopes on Earth, and yet all I could see was fuzzy blobs.
Uranus was a small bluish-green dot in the telescope, and Neptune was an even smaller bluish dot, and that's all.
Astronomers had worked pretty hard to know what physical makeup was. There were some basic characteristics, but their real nature, in terms of weather, in terms of distribution of mass inside, what they were really made of, what the moons were like, we had none of that, just little glimpses.
There's a limit to what you can learn just looking through a telescope from Earth. There's theory, but then there's unknowns, and we're researching the unknowns.
Human beings are a curious bunch. We want to know what's around the corner. We have to go past that next bend in the road. So it's some sort of innate drive, I think, that we have as a species.
I think this innate desire to explore conveys an evolutionary advantage to us. We look to improve our circumstances, and I think that there is a feeling that our survival as a species is going to depend on our learning how to live on other worlds.
It's a very human thing to ask questions. It's a very childlike thing to ask a million questions. And some of us never grow up.
One of the key things that made this mission possible was gravity assist. That is, when you fly by Jupiter, you turn the corner and you take a little bit of Jupiter's orbital speed with you, like a slingshot. So you better make sure Saturn's in the right place.
We were very fortunate that we had an alignment.
Jupiter, Saturn, Uranus, and Neptune would all line up.
So we go Jupiter, boom. Saturn, boom. Uranus, boom. Neptune, boom.
The planets had to be lined up in just the right way to allow one spacecraft to do that.
And that lining up only occurs rarely.
That only happens once every 100, more than 100 years.
175 years, something like that.
Once every 176 years.
The previous time it happened, exploration was wooden sailing ships.
It was named the Outer Planets Grand Tour, and the cost of the mission was estimated to be in excess of $1 billion. The NASA administrator went to the president, and he said, the last time the planets were lined up like that, President Jefferson was sitting at your desk, and he blew it. So Mr. Nixon laughed. He said, oh, all right, just do 2. So only 2 planets. And of course, the price tag consequently was substantially less. But we all knew that the launch was in 1977, which would be after Mr. Nixon's second term. And of course, it turned out that his term ended a lot sooner than even he thought.
Voyager started as a project in July of 1972, and we had 11 scientific instruments, 11 different teams, and the mission success was 1 spacecraft past Saturn.
But we knew right from the get-go that we were going to try as hard as we could to extend the mission to go to Uranus and Neptune.
We selected trajectories to pick a target point at Saturn that would give us an assist to Uranus. And so we designed that in from the beginning. We knew that we were endowing Voyager with the option if the chance was there to use it.
We didn't want to build anything into the design that would have prevented us from going further. So It was a mission within a mission, yeah.
The golden record really is the kind of heartbeat of the ship itself. The reason why it's going there, it's certainly exploring, but it's the lifeblood is that record.
I remember all the publicity on Pioneer 10 and 11 spacecraft where they had some line drawings of a male and female form. And, well, you know, and some people went absolutely bonkers. I don't know if you've seen it, but it's the most innocent thing you can imagine, you know, and it caused a lot of commotion. But I thought that was great.
Would you expect someone to find this record out there? Is there something out there?
Well, nobody knows. One of the great unsolved questions is whether we're alone or whether...
Carl Sagan has become probably the best-known scientist of the late 20th century. He was a working scientist. He played a key role in many of the NASA missions to the planets, including the Voyager one. He was one of the scientists on the Voyager imaging team. But he also was the astronomer who, as much as any one person, made the study of extraterrestrial life credible.
A comment by Thomas Carlyle, somewhat crusty old fellow, who, upon thinking about the stars, said, "A sad spectacle. If they be inhabited, what a scope for misery and folly. If they be not inhabited, what a waste of space."
Carl Sagan was a good friend of mine, and I called him up and said, "Hey, would you be willing to undertake to come up with something for us to put on the Voyager spacecraft?" He says, "Yes, sure." And he told me he could do it for $25,000. So I authorized him to go ahead and do it, and I sort of was hands off at that point. The whole creation was his and this group that he put together.
They figured, don't let this opportunity pass. You're going to throw a message in a bottle into the ocean, put a message in it. And so they decided to put time capsules in those bottles.
And at first, Carl thought they'd simply do another plaque, maybe with some more information. But Frank Drake, who a brilliant man, a kind of a cross between Albert Einstein and Thomas Edison, brilliant theoretical physicist, but also a very hands-on kind of guy who can solve practical kinds of problems. He came up with the idea that for the same amount of weight and space, you could send a phonograph record.
The people who actually did the science part of Voyager are always jealous and mad because the golden record gets more attention than all the wonderful things they did exploring the outer planets of the solar system, except Pluto and all that. But the main attention goes to the golden record. Because of the aura that surrounds anything to do with extraterrestrial intelligent life, any kind of effort to contact extraterrestrial life is more fascinating than knowing the chemical makeup of a mineral on Mars or something.
The record is an old-style LP recording. The only difference is it's on metal, and that's so it will last a long time.
And it was recorded at half speed, so that gave us 2 hours of total time. An hour and a half of it was devoted to music, and the other half hour contains all of the other data on the record, the natural sounds of Earth, the spoken greetings, and the encoded photographs of Earth.
One of the first questions a lot of people ask is, well, they'll never figure out how to play it. And in fact, we included a cartridge and stylus in the package with the record, and the drawing on the cover of the record shows the method by which the stylus is to be placed on the record.
Maybe what's written on it will seem like kindergarten scribbles to them, but they should be able to figure it out. They've got some smart minds or whatever's in their heads, if they even have heads.
Voyager launched at the 100th anniversary of the development of the phonograph record by Edison. And so it was the natural medium to put the information on. But what I find interesting is to protect it from the dust and tiny particles of the journey, they put a cover over it. And on the cover was engraved the location of Earth, or our solar system, in terms of its direction from different pulsars.
A lot of people say, well, why would you do that? I said, what do you mean? And he said, well, why would you announce where you are? You know, because there are aliens out there that probably raid planets and use them for food or eat the people or make them slavery. You know, if they find it, their technology is probably more advanced than ours, they'll come here and destroy it. So why would you do something like that? So if somebody did find it, they would be thinking that way, and they say, why would these people expose themselves to our voracious appetites or whatever it is? They must be very altruistic, you know.
The chance
that advanced intelligence beyond us would detect, oh, hey, there's a radiating body coming into our area. Let's go out and find out what this bottle in the ocean, what message it might have. Now, is that a grand mystery? Whoa.
Well, that brings up the whole question, is there anybody out there? Listen, there are, give or take, 200 billion stars in the Milky Way galaxy. There are about 200 billion galaxies in the universe, or at least in the universe we know about.
It's a pretty small spacecraft, and it's a pretty big universe. If you take a piece of sky the size of a soda straw up there in the Big Dipper, in that tiny piece of what we thought was blank sky, there's thousands of galaxies. And each one of those galaxies is filled with billions of stars. That's just the soda straw, and now you imagine the whole sky filled with thousands and thousands and thousands of galaxies, each of which is billions and billions of stars. There's a lot of possibility out there.
If you took a grain of sand and put it on a table, and if that were the size of the sun, then the Earth would be about an inch away, and it would be microscopic, and the entire solar system would fit on a table 6 feet across. Think about the next star. The next star would be another grain of sand. How far away from that solar system would you have to put that? And it turns out to be about 7.5 miles away. It's absolutely remarkable how much space there is between the stars and between the planets.
The distances are almost unfathomable. These were the fastest spacecraft that had ever been built and launched and flown, and they're traveling at 10 miles per second. You wouldn't even see it, right? And yet, even at those unfathomable by Earth standard speeds, it takes decades to get out there into the outer solar system.
We don't have any problem putting the spacecraft through the asteroid belt, yet at one time people think, God, we're going to crash into an asteroid. There's not very much chance of crashing into an asteroid. There's just a lot of room out there, a lot of room.
If you want to realize how empty our galaxy is, the nearest galaxy to our own is Andromeda. It's about 2 million light years away. It's on a collision course with us right now. And in 5 billion years, that galaxy is going to collide with our own. And you might say, oh no, oh no. Well, it turns out space is, even in our galaxy, it's mostly empty space. When our two galaxies collide, almost no stars will hit any other star. It's mostly empty space. So Voyager is likely to continue throughout our galaxy for potentially millions or maybe even billions of years without a collision.
I have a hard time with really long geological time frames. You just can't get your hands around how tens of millions of years, what that really means, and distances, astronomical distances.
Yeah, once you start getting into the astronomical scales, our solar system is pretty tiny. And so this adventure of Voyager, which seems so remote and distant for this little spacecraft to go out to the giant planets, is really just exploring the tiniest, closest neighborhood when you start thinking about cosmic scales.
The spacecraft were built at the Jet Propulsion Laboratory. It's a federal research center that's part of Caltech, and they build spacecraft. One of the things I just admire most about the engineers who built Voyager is that they're always thinking about the most improbable things happening. You know, you want to take those people on a camping trip with you because they will think of, well, you got to bring, what if these bugs come out? What if the tent gets flooded? What if you run out of gas? What if you can't start the fire? You know, they're the what if people. And when you're sending something out into space, you can't go do a service call. You can't bring it back. So your what if list had better be like that long, or you're not going to be able to survive.
These projects begin with a conceptualization period. How feasible is it for us to do thus and so? We didn't know what the spacecraft was going to look like. How do we arrange the spacecraft? How do we take the communication system, this large 12-foot diameter fixed antenna, and arrange it relative to the propulsion system, the spacecraft took on the dimension of being a child, and our design teams, were like kind of parents. This was actually a nurturing process, bringing that child, if you will, into reality.
All spacecraft are made basically of the same thing. It's silicon and aluminum. That's about it. That's probably 95% of it. Silicon and aluminum is cheap until you start making stuff out of it,
The spacecraft, of course, is quite primitive by modern-day standards. We have 3 computers on board. Their total memory is about 240,000 times less than in your smartphone.
1972 was when you had the technology freeze. Remember, we launched in 77, so you freeze technology several years earlier. And at the time, the biggest computers in the world were comparable to the kinds of things we have in our pockets today. And I'm not talking about a cell phone. I'm actually talking about a key fob.
What's wrong with 70s technology? I mean, you're looking at me, I'm a 30s technology, right? I don't apologize for limitations that we were working with at the time. We milked the technology for what we could get from it.
Voyager is about 800 kilograms. Its main antenna is 12 feet in diameter, which is the largest we could launch.
There's this body, this 10-sided can called the bus, and that's got all the electronics and the computers. And it's got these arms and these appendages that stick out. There's these feet that connected it to the rocket, and then a really long arm with a magnetic field sensor on it over here, and another arm over there with this plutonium power supply to give it its electricity. You can't keep that too close to the spacecraft because it'll radiate the spacecraft. And another arm with this device that had the cameras and other instruments on it that could point around, kind of like the eyes, and the big antenna was the ears. When everything is fully extended to its greatest dimensions, it's comparable in size to sort of a small school bus. It really is graceful, despite the kind of gangly appearance. A strange-looking being for our planet, but perfectly happy in space.
I became the producer of only one record in my career, and only 2 copies of it were made, and they were both hurled off the Earth, so I don't know if that's a credential or not. The launch window for Voyager was set. It had to do with an alignment of the outer planets. You have to launch in that window, and they sure as hell weren't going to wait for the record.
We had 6 weeks to do it. And when I talk about the record, I think that's what always draws the biggest gasp. That you had to figure out a way to explain the world to aliens, and by the way, it has to be finished in 6 weeks.
We had 2 goals in making the Voyager record in terms of the music. The first was we wanted the music to represent many different cultures around the world, and not just the culture of the society that had built and launched the spacecraft. The other criterion was we wanted it to be a good record.
It's a very idiosyncratic message. It doesn't seem like something made by a committee. It's too quirky.
Nowadays, you'd work a lot on the internet. Than those days, it was more sitting in the dark, listening to pieces of music, making notes. It takes a long time to go through a stack of records that's that high. If you were listening to the Voyager record, it would be remarkable if you didn't hear some pieces of music that were quite unlike anything you'd heard before. The Japanese shakuhachi piece, or the 16-year-old pygmy girl singing, it's called an initiation song, kind of puberty song, in the Turi forest of Africa, is just unbelievably beautiful. The Javanese gamelan piece is just beautiful. The Chinese chin piece is the sort of thing that will never leave you. It was a terrific, mind-expanding adventure. There was a certain amount of hunting up rare records here and there. I remember the back of an Indian appliance store in New York where they had some Indian records, and there was one copy of a raga that we ended up putting on the record.
Always the criterion was that we were trying to describe our culture. So it would include folk music and primitive music and Bach and Beethoven and jazz and all of that. And something we wanted very much was the music of the Beatles. And they said, no way. And we said, well, this is all going in outer space. It will never be heard on Earth. No, we don't do it. They don't license for outer space.
I would have loved to have had a Bob Dylan piece, but really there's only room for, at most, one contemporary rock piece. But you know, you're up against Chuck Berry's Johnny Be Good, which Bob Dylan himself would admit is an awfully good single.
It may be just 4 simple words, but it is the first positive proof that other intelligent beings inhabit the universe.
What are the 4 words, Kakua?
Send more Chuck Berry.
The world is full of fantastic music, and it goes without saying there's a lot more great music that's not on the Voyager record than there is on it. Which is a good thing, too. I mean, imagine living on a planet that was so pathetic that it only had 90 minutes of decent music.
Flight control to launch enable. Roger.
A countdown will begin at 10 minutes before midnight tonight.
Journey about to begin, which will take the technology of Earth out of our solar system.
When it was launched, it was, of course, all folded up. It was like origami.
Here was this almost unexpected encapsulation. I mean, we knew that we were going to be encapsulated, but the emotional effect on that was kind of surprising. I noticed that in just looking around me. I realized that this was the last time any of us were going to see this spacecraft with eyes. And that's a fairly moving experience.
Environmental control ready. Roger.
We actually launched Voyager 2 first, and this gave the media, drove them nuts. We launched Voyager 1 later, but it was launched on a faster trajectory. So it overtook Voyager 2 in December of 1977. From that point on, Voyager 1 always got to the planet before Voyager 2, and the press was happy. They understood it.
Most of the press release drawings show the other side of the spacecraft, so you can't see the Voyager record. But when the reporters came to the launch, they all wanted to know more about the record. There was always a lot of ambiguity at NASA about this. There's no question that the Voyager record is useless from a scientific standpoint. And the officials reluctantly arranged a press conference. The press conference was a joke, really. It was held in a hotel room separated by one of those accordion folding barriers that you pull across to make one room into 2 smaller rooms, from what was literally, as memory serves me, a Polish wedding reception. We did the whole press conference with the oom-pah sound of a wedding reception next door. But I think the public seemed to get it.
We have just had a report from John Cassani, the Voyager project manager, that will be able to count down at 10:25.
They were launched on a Titan launch vehicle, which were intercontinental ballistic missiles for a long time, and some of them, as they were decommissioned, were turned into rockets to launch spacecraft out to the planets.
5, 4, 3, 2, 1. We have ignition and we have liftoff.
You see those solids ignite, and you're really not prepared for what's about to occur. The sound waves then catch up, and then this forceful shaking. The body is actually moved in resonance with this energy shaking you, right?
We jumped up and down, big hugs, you know. We were so happy to have gotten away with it. And the rocket worked. You never know about that either.
We were sitting in bleachers, and they keep you pretty far from the launch vehicle because they can explode, and basically it's a big bomb.
So there's a little bit of holding your breath and wanting to make sure you see it get that first little motion off the pad starting into space.
When we saw that going off into space, we were all thinking this thought, there it goes. And it's going to be out there to represent us for the next 5 billion years.
I was a 7-year-old child watching it go and thinking like, oh, I had some small thing to do on that. Like there's some part of me on that, but no real significance. But it's like, oh, that's, yeah, okay, bye.
There were outbursts of joy. We were on our way.
And then we launched it, and then other things went crazy. The spacecraft began to do things that we had no expectation that it would have done.
Us poor people on Earth were like, what is it doing?
As the launch vehicle leaves the launch pad, it has to roll through a certain angle to get to the right direction for departure. And the rate that it rolls at is a much higher rate than the spacecraft would ever normally experience flying. And so the gyro hits the stops, it saturates.
Voyager was not in control of itself. It's just riding this big rocket. And that was shaking it in such a way that it thought it was failing. And so it started switching off various boxes, changing to the backup this, to the backup that, trying to figure out why all this stuff was happening.
For a couple of days, it was a real nail-biter. And people were asking us, have you lost the spacecraft? And we would say, we don't know for sure, because we didn't know for sure.
And the headline read, "Mutiny in Space." The Voyager spacecraft had decided it just didn't want to follow the instructions that its human controllers were giving it, and it was going to do what it wanted to do.
Fortunately, the person who had written that code was able to say, this is okay, it's doing this, it tried that, it's doing this, it tried that, and calm everyone else down.
All the time it was doing that crazy stuff, is it doing exactly what we had designed it to do all along.
The limits were set simply too tight. It needed to be able to wiggle more and vibrate more, and the telemetry link wasn't going to be as solid as people expected. So all of those things that had caused issues with Voyager 2 then were solved for Voyager 1.
Centaur 6, Titan Centaur 6 is lifted off at 8:56 from here at the Cape Canaveral Air Force Station.
When Voyager 1 lifted off, we're thinking everything's okay. And then we begin to hear this, we call it chatter over the launch vehicle net, that something wasn't right.
I looked over at him, and he looked like he was a little worried, you know, and I says, what's the matter, Charlie? And he says, I don't know, I don't think we're gonna make it, you know. There was a leak in the propellant line, and we were losing propellant overboard. So while it was burning, propellant was escaping from the launch vehicle. And that's why second stage never got to deliver this full thrust, because it ran out of fuel.
And so the upper stage, which was a Centaur, liquid hydrogen oxygen stage, had to make up for that.
And the Centaur is the stage that's doing the guidance. So the Centaur knows that it's not reaching the required velocity. And when it separates from the second stage, it knows it has to burn longer to add more velocity.
The Centaur, to achieve parking orbit, had to use 1,200 pounds of extra propellant. Now we're all thinking, is it going to have enough left in the tanks to make a normal injection? Or is it going to run out of fuel? Fortunately, it had 3.5 seconds of thrusting left before it had run to fuel depletion. 3.5 seconds. So Voyager 1 just barely made it.
It wouldn't have gotten enough velocity to get to Jupiter, you know. So instead of getting to Jupiter, you know, we'd have gotten almost to Jupiter, and then we'd come back toward the sun, which would not have been good.
I watch the distant lights go down the runway, disappearing through the evening sky. Oh, you know I'm with you on your journey, never could say goodbye.
And then, of course, you know, there's the thought that it's out of our hands. Now the major reason for this mission was about to unfold, that is the science. But our role as keepers, as progenitors, as our role had been finished.
It's just the phase you're going through.
That was moving.
Break away. away, fly across your ocean, break away. Time has come.
It's worth realizing that a human life ago, less than 100 years ago, 87 years ago, the universe consisted of one galaxy, our Milky Way galaxy, in a static, eternal universe with eternal empty space. We didn't know about the other 100 billion galaxies a single human lifetime ago. And we didn't know that the universe was expanding, and it was born in a Big Bang 13.7 billion years ago. But even stranger things, like the things I work on, the fact that most of the mass of our galaxy is invisible. It's made of stuff other than you and me. We think it's made of some new elementary particle that is actually going right through you and me right now and right through the Earth without even noticing it was there. Even stranger than that is the fact that empty space weighs something. You get rid of all the particles and the radiation, you have nothing there, and it weighs something. And moreover, it's the dominant energy in the universe, and we don't have the slightest idea why it's there.
You can never really imagine, you can try, but you can never really imagine what Mother Nature will actually have in store when you get there. It seems like time really flew.
I don't think we really fully understood before the first Jupiter encounter just how intense it was going to be. No, we didn't. We found out.
It's an interesting phenomenon that you start working on a mission in 1972, you launch in 1977, all of that, there's no science. It's all getting ready. And then, March 79, the flood.
The encounters, they creep up on you.
We started what we call the observatory phase with our long telephoto camera, and that's when we started seeing day by day larger and larger Jupiter.
When we were approaching, every picture was the greatest picture ever taken of Jupiter.
In the beginning, it would be just a little dot getting bigger on the screen every day. And as we would get closer and closer, the images became more dramatic.
Incredibly strange and beautiful, and now by Voyager revealed in all of its splendor.
We were trying to get as much detail as possible, so the narrow-angle camera was 1,500 millimeters, and the wide-angle camera was 200 millimeters.
Would someone care to speculate what you would say to Galileo Galilei if he walked into the room today?
How are you able to live so long?
I think Galileo...
Jupiter is more than 10 times the diameter of Earth. It's huge. And it's mainly hydrogen and helium. There are no solid surface on these planets. These planets are liquid, gas and liquid, deep inside.
The gas is compressed the farther down you go, and it gets very hot indeed. And you would melt, vaporize, in fact, if you tried to fly through Jupiter.
Let me first modify your statement, not that it was wrong.
The atmospheric scientists got long-range views because we weren't looking at tiny moons, we were looking at the big planet. And so we could see things going on before the other groups could see things. And we were always the first to start shouting.
Even to this day, we don't fly color detectors. You get a much higher resolution image in black and white. And so when we want to make color, we take them through different filters, and then on the ground, you put it together and make a color image out of it.
That acceleration as you're approaching encounters is really something that becomes very, very exciting. We call it drinking out of a fire hose. You know, you're trying to take a little sip, and this torrent of data is coming out.
You go to Jupiter and you have a storm that's been around for more than 300 years. That's the Great Red Spot.
You could fit 2 or 3 Earths inside it. And so here's the great red spot, here's an Earth, here's an Earth. It's always going around. And I sort of assumed that the flow around these giant things would be smooth like honey. But when Voyager started getting close-up images, we realized that it was very active. And that deepened the mystery of how these big storms could even exist with all this turbulence going on.
It was swallowing up clouds and spitting out others. We knew that it was a vortex, but to see it in action.
Every day you're wondering, did we build a spacecraft well enough? Did we anticipate all the possible things that could go wrong?
Pioneer 10 had to measure the radiation environment, which was much greater than our Earth-based interpretation suggested.
You're approaching this monster, essentially, this monster magnetic field, this monster radiation environment on purpose, because you need to get close, because you want to see all the little moons and the clouds and the storms, and you want to slingshot onto Saturn, but you just don't know if you're going to survive. Thing gets fried, you lose the mission. Still out there, physically intact probably, but unable to communicate with it, the mission's over.
2 months before shipping to the Cape for launch, the scientists were predicting that the magnetic fields around Jupiter were intense enough that they would accelerate particles. Whoa, we were hearing initially 40,000 volts. That would be the end of our spacecraft. Cabling on these appendages were conductors that would take these destroying pulses and just feed them right into our systems and kill us. So we needed to ground everything. We didn't have time to go through the normal design reviews. So in order to get this protection done quickly enough, an ad hoc team was formed. And we did some things that were out of the ordinary, very out of the ordinary. I can remember asking one of the technicians to go out and buy aluminum foil. It was the only material that was available to us. Normally, our procurement of spacecraft hardware, supplies, materials are a much more sophisticated process. We're all in bunny suits, actually cutting continuous strips and then cleaning them with wipes and alcohol, and then finally wrapping these on all of our exterior cabling. But yeah, same material as in your Christmas turkey. I don't think we created any shortage per se. It may have been a local shortage in the local grocery store for a few days until they reordered, right? Your turkey wrapping is protecting Voyager. And now, fast forward, did we know whether we had done enough?
Amazingly, we heard all kinds of sounds. It's a very curious phenomenon. You don't expect the molecules up in the corner of a room to suddenly get together and start whistling at you. But in a plasma, in this radiation belt, that can happen. I'm going to call them radio sounds because we have to detect them with antennas. If you had the right kind of antennas on your ears, you could go out and hear what we record. Whistlers, these things that go like that. Yeah, whistlers mean lightning. That was the first detection of lightning on a planet other than Earth. Much more intense. There are lightning flashes at Jupiter that would go halfway from the east coast of the United States to the west coast. So it's fascinating what you hear in space.
When you're on a flyby mission, there ain't no second chance.
We were getting pictures, they were getting better and better, and you could begin to see detail as these moons got bigger. The dread you have is that you don't want to see a lot of worlds that look like Earth's moon. Let's face it, it's dull.
Our mind's eye was, oh yeah, we're gonna see battered ice balls and so forth. And when we saw Callisto, basically it's totally hammered, right? Saturated with impact craters. Ganymede shows a lot of interesting grooves and ridges, but it's pretty blasted with impact craters. And then as we went into the inner two,
you could not see craters on either one of them. Well, this was encouraging because now we think maybe this mission is going to find a lot of diversity.
Discovering this billiard ball smooth icy crust of Europa with cracks in it and what look like plates of ice that might be moving relative to each other. The best explanation for that is that there's a thick ocean of liquid water, salty water underneath that icy crust. More ocean water than on the entire Earth, probably 2 or 3 times. It's the largest ocean in the solar system, and a moon going around Jupiter.
And then, of course, kind of the showstopper for Voyager, we get to Io.
Io, of course. Io was the star of the show. And we didn't learn that until after the encounter.
Everyone had gone home, and Linda Morabito, an engineer whose job was to find out the positioning and the orbit of the spacecraft, noticed some bumps on images of Io.
I was on the mission as a mission navigator, and our job involved just looking back over the shoulder of the spacecraft to say, okay, one more picture of the realm of Jupiter. So it wasn't high priority work.
It was an optical navigation image, and Linda saw this strange thing on the limb.
An enormous object emerged, enormous. And the first thing I said to myself, what is that? And I'm like, it looks like another satellite in the picture emerging from behind Io. An object that size, at that range, at that distance would have been seen from Earth. It was sufficiently large. I felt with certainty, it was the only thing I knew, that I was seeing something that had never been seen before. This was an umbrella-shaped plume rising 250 kilometers above the surface of Io with volcanic activity. I found the very first evidence of active volcanism on a world beyond Earth.
It was so hard to believe that a little moon could have 10 times the volcanic activity of Earth, which was the only known active volcanoes in the solar system were here on Earth. And then there's Io. Suddenly, we had realized this was a different journey we were on.
I wanted to say one other thing. We've been saying that perhaps there's some funny way in which Jupiter gobbles up all the things that are coming in and doesn't let Io be hit by any. Well, we aimed a spacecraft and went very close, and had we missed, we would have made the first impact crater. The flyby is basically a week-long affair that's 24 hours a day. It's intense.
There will be a Voyager report in 30 seconds.
Instant science, because there's going to be a press conference that night. This picture comes down, and you've got 3 hours to figure out what's going on, and then tell the world about it. Oh, no pressure there, right?
The confines of being a piece of biology got in the way of that. I mean, you got hungry, you got tired, you had to go to the bathroom. I mean, you're going to miss something. You don't want to miss anything, because every 48 seconds a new image would come down.
No one got any sleep during one of these flybys when the spacecraft would go zooming past. The photo labs were working day and night, and people were sleeping in their cars.
It was just way too exciting to sleep. This is the first picture ever of Jupiter's ring.
Jupiter was really just wonderful. It was just discovery after discovery.
You don't get something for free. Energy and momentum have to be conserved. So when Voyager picked up 35,000 miles an hour of speed, you actually, during that swing by slowed Jupiter in its orbit by 1 foot per trillion years.
Jupiter was a game changer. Jupiter reset all the registers. Now we're really up for something. And to know that this was just the very, very beginning of this journey. If we're blown away by Jupiter, just wait until we get to Saturn.
Voyager to me was Homeric. It was years of passing across the solar system from one planet to the other, and then it was a week or two of frenzied activity and discovery and conquest, and then it was, well, back in the boats, oars in the water, and then on to the next conquest.
My father was Carl Sagan, and my mother is Linda Salzman Sagan, and she's a writer and an artist, and she designed the iconic Pioneer plaque. She actually drew it, and she's the one who got all of the greetings for the Voyager Golden Record. I like to think of her that she kind of put together a kind of choir of voices of greetings to the stars. My parents wanted a child to have a voice as one of the voices, and they just came to me one day and said, Nick, if you'd like to leave a message to aliens if they happen to exist, what would you like to say to them?
Hello from the children of planet Earth.
Oh, hello from the children of planet Earth. That's what I would say to aliens. And they loved that, and so it's like, great, let's record you. It's a bit of a blur. Like, the only thing that I know that I remember from that time is those knobs and the little recording level that goes into the red if you speak too much, this 70s kind of... So I remember that, and I remember watching the needle move as I spoke and seeing, like, where it got... Oh, that got close to the red, but that actually didn't go into the red. Okay, that's probably good. And there's my not-so-great, like, handwriting from age 6. Not that it's so much better now. This is hello from the children of planet Earth. And I think I have a little hyphen because I ran out of space for planet. And then I was drawing something that I thought later was a tree, but other people told me it was a rocket ship. And I think I was more focused on my crappy drawing than I was in whatever, performance of how I was going to say this line. And that was that. And then I, drank my apple juice and went back to my books. It was really not till considerably later that the kind of enormity of what that meant actually hit me.
Oiknis poteste chairete, eirenikos pros philos eleluthamen philoi.
Siyanibingelela maqhawe, sinifisela inkonzo ende.
The reason I was chosen was not because I'm something special. I happened to be there at the right time, at the right place, and people knew that I speak Arabic. So I was lucky.
I said, why me? They said, because you speak fluent Portuguese.
I didn't get any instructions about what to say, except that it needs to be short.
The greetings to the universe are almost like proto-tweets. The first tweets, keep it short, keep it simple. And I had about 5 minutes warning before I was recorded. They said, we're making a record to go aboard a spacecraft, and that was very intimidating.
सब लोगों ने मारो राम राम पहुंचे हमें अठे राजी खुशी हां तुम उठे राजी खुशी रह जाओ.
It's not like there's a rule book for what you should say when you're greeting the universe.
पृथ्वीवासीहरूबाट शान्तिमय भविष्यको शुभकामना.
Paz e felicidade a todos, which means peace and happiness to everybody. It seemed like a safe thing to say if you ran across some aliens rather than saying, take me to your leader or whatever.
各位都好吧，我们都很想念你们，有空请到这儿来玩。
Because the equipment is cold, the spaceship is inanimate. Even the record itself is metal and, I just wanted my voice to convey warmth and to make contact. تحياتنا للأصدقاء في النجوم يا ليت يجمعنا الزمان. And it means greetings to our friends in the sky. We long to meet you someday.
There is some piece of me that is a traveler on that ship.
It's just gone. It's just going. Continues to go. It's going to keep going. When I'm long, long gone, it'll keep going. And it's like a little piece of magic.
Hello from the children of planet Earth. Planet Earth. Planet Earth.
In your mind, you have capacities, you know, to telepath messages through the vast unknown. Please close your eyes and concentrate with every thought you think upon the recitation we're about to say. Calling occupants of interplanetary craft.
I'd like to know the answer. Are we alone? I'd like to know the answer to that question.
There has to be other civilizations. The numbers just compel it. It would be almost statistically impossible for there not to be other life forms and other life forms that have evolved to a state of intelligence and beyond.
The bigger you think space is, the more probability there is that they're there. The less probable it is you're going to find them because they're needles in infinite haystacks.
I'll tell you, I think that intelligent life, if we can include ourselves in that categorization, is so prevalent that I'll bet you at this very instant, there are two people, probably one male and one female, having exactly the same conversation that you and I are having right now. I think that's how prevalent life is in the universe.
You're probably trying to contact us at this very minute. I predict passing through this room right now radio messages that we could detect with equipment we could build if we knew where to aim that detector and what frequency to tune to. And it's right here in this room, and that's just mind-boggling. You know, they're here. They're right in the room right now.
The big division with extraterrestrial life is not space, it's time.
It depends ultimately on how long our civilization lasts and how long civilizations last, because you've got to get them to overlap for us to communicate.
In our galaxy, our sun is relatively young. The galaxy is about 12 billion years old. Our sun's 4.5 billion years old. There are many stars that are a lot older. Therefore, you could have imagined some civilization around such a star that might have watched our Earth form over the last 4.5 billion years. Well, over that last 4.5 billion years, the only evidence of intelligent life would have been in the last 50 or 60 years by watching Star Trek or I Love Lucy or whatever signals we sent out. So even if someone told you, look at that star, and then look at the third rock from that star, and that's where you're going to find life, even if they knew which object to look for, there's only a 50-year period over 5 billion years almost where you'd be able to find intelligent life.
If we're alone, then we're truly unique. And how did that happen? And why us? And how are we so special and yet in such a kind of far-flung, kind of humdrum part of the universe? And if we're not alone, how did we all get here? And can we learn about ourselves by these other groups out there? And what are they like? And are they the creatures of our dreams or our nightmares?
I think what's going to save us is that interstellar travel is much harder than we think, and we're safe for quite a long time from the aliens because they don't know how to travel very far either. We're all sort of stuck on the planets we've got.
The thing about the Voyager mission from Jupiter to Saturn was the short space between those. Jupiter to Saturn went just like that. It was really quick. It's easy to think of Jupiter as the bully. It's the alpha male of the solar system, no question. I think Saturn is majestic, with the rings giving that sense of beauty and serenity. And the moon's sort of subservient and somewhat pushed aside.
We started off with images that were probably no better than what you can get from the ground, and then it keeps getting better and better and better as you get closer and closer. What are we going to see when we get really close?
having seen Saturn in a telescope with the rings just looking like these little tiny ears on either side, to now seeing detail and the beauty of Saturn's rings, looking like almost like the grooves on a phonograph record.
The rings of Saturn, what are they? Billions of icy particles, some the size of a house. They're enormous, much wider than many Earths strung together, but less than a kilometer thick.
We get there and we find that it's a blizzard of features throughout the rings, and it got very complex. Become junkies. This is how you become a planetary flyby junkie. It's because you've gone through one of them and you just know it's the greatest feeling and you want to keep doing it again and again.
At some point, perhaps a year or so from now, it may be possible to put all this into perspective. But right at the moment, I cannot recall being in such a state of euphoria for any previous planetary encounter, including our two remarkable Voyager encounters at Jupiter.
Largest moon of Saturn, Titan's the most extraordinary place. There is a dense methane atmosphere where a complex organic chemistry has been going on for perhaps billions of years, and we are in a moment of extraordinary discovery.
We had both spacecraft programmed to do a identical mission at Saturn, and that was the prime mission, and it involved Titan.
There's a huge amount of scientific interest in Titan because many people think that early in our own history, our own planet may have been like that, with very little oxygen, lots of hydrocarbons, very thick, different, smoggy atmosphere that was changed dramatically on our planet by life. So if you want to understand the starting conditions, go study Titan.
If Voyager 1 was successful at Titan, Voyager 2, which is 9 months behind going to Saturn, would be free to continue to Uranus and to go on to Neptune. But it depended upon Voyager 1 succeeding at Titan.
Because Voyager 1 had to be in a certain place in order to pass Titan, it couldn't go on to Uranus and Neptune. There was just no way to bend its trajectory to go anywhere else.
Voyager 2 would have done exactly that same thing if Voyager 1 had failed. We would have gone like this, no more planets.
That would have been really tough. You're going to try for Titan again and give up 2 other worlds, Uranus and Neptune.
So there was a lot of pressure on Voyager 1.
Mostly what we looked at was a giant ball of brown smog with some sort of electric blue hazes above it.
With the Voyager camera, you couldn't see through the clouds and haze. Now, the radio signal from the spacecraft passed through the atmosphere of the planet, and that gave them a measure of the pressure at the surface and also the temperature at the surface. And so we learned a lot about Titan from that radio signal.
Titan did not reveal itself to the cameras of Voyager, but the spectrometers and radio science made major contributions to the chemistry and physics of the atmosphere and the interior.
We had gathered what we could with Voyager spacecraft.
There was little to be gained by doing another close flyby of Titan.
Shortly after that, NASA headquarters agreed that we should continue with Voyager 2 on its Uranus trajectory. So Voyager 1 had succeeded.
People don't realize how we almost didn't have that mission to Uranus and Neptune. We almost didn't have the Grand Tour, if not for the success of Voyager 1 at Titan.
Voyager 1 was done and was receding from the solar system at an angle above the plane of the planets.
So Voyager 1's planetary mission almost ended right there. Come back to that later. getting pictures and other data back from Voyager 2. But at some point in time, it had to go behind the planet, and that blocks us from getting radio signals to the Earth. And that happened to be in the middle of the night. It was a period of time, several hours, that everybody knows we're going to be out of contact with the spacecraft. Everybody's expecting to pop champagne corks and say, hey, we made it, and all the data's on the tape recorder because it couldn't be transmitted to the Earth. And instead, it pops out of the other side, and there's all these crazy error signals coming from the spacecraft. Something bad has happened.
Something happened right around ring plane crossing, and the images that were coming back were blank.
People thought maybe it crashed into the rings of Saturn. Is this it? Is it dead?
Ladies and gentlemen, we can start the briefing.
I wanted to make a very brief statement. We do have a problem on board the Voyager 2 spacecraft.
The spacecraft has a problem. The scan platform operating mechanism is not operating properly.
To make sure we understand where we're headed, the following instruments are mounted on the platform: the wide-angle camera, the narrow-angle camera, the infrared instrument, the ultraviolet instrument, and the photopolarimeter.
Yeah, that was the darkest day of the whole mission.
There is circumstantial evidence.
I came into the auditorium and there was just gloom on everybody's face.
You're beginning to speculate.
I quickly learned what had happened. The scan platform had frozen.
We were moving our scan platform all over the sky, and we're actually going as fast as it could possibly go.
A frozen scan platform could be a fatal, crippling event.
We have our speakers up.
The rest of the Saturn mission and Uranus and Neptune were dead. And seeing everything that we were planning just gone, just suddenly gone.
The problem is not with the camera, it's with the articulated platform that moves all of the instruments. Our cameras, as far as we know, are working just fine. It's just that we're taking lots of pictures of black space.
All of the science that we had hoped to do in Uranus and Neptune, there were no other spacecraft that were going to be going there. It was up to Voyager to do it, and all of a sudden it looked as though Voyager's not going to do it. It was devastating, it was.
It took a couple of days while the engineering team went to work diagnosing the problem.
We are going to command an azimuth salute and an elevation salute to the Saturn position.
It turns out the scan platform, it has small motors to rotate it, and we could run it at slow speed, tick, 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 fast, medium speed, or very fast. We were, of course, wanted to look at lots of places, so we had the thing looking lots of places, and the lubrication wasn't adequate, and it just jammed.
It was frozen, sort of like a car stuck in the snow. You try to go forward or backward and a little bit, and keep working on it and try to get it out, and that's what we did with the scan platform. We would try to push it a little bit in one direction, and it would yield a little bit, and then we'd push it in the other direction, and it would yield a little bit more, and then we kept doing that back and forth, back and forth. And finally, that was enough to get the lubrication into the gears.
It was freed up, and back came the spacecraft, and back came the imaging system, and there was Saturn on exit.
Yeah.
We were looking at the shadow of Saturn on the rings, and it was clearly from this wild, crazy angle. Wow, holy cow, we're on the other side of Saturn.
Felt like we were there. Nobody even thought about it. Voyager was part of us. We.
And you
planetary exploration, to me, is a story about longing. It's a longing to know ourselves. It's a longing to understand the significance of our own existence. It's a longing to communicate, to say to the universe, we're here. You know us. Where are you?
How would you go about trying to communicate with a totally alien civilization?
The assumption is that we share the same physical universe, that the laws of physics here on Earth seem to be applicable everywhere. Science and math will be something that we can communicate with them fairly easily.
Humans universally love music, and so the record says, we like this stuff, and we send it out as a kind of gift for you. Beneath that, there are mathematical structures. The mathematical structure of a straight pop song is pretty simple. It's like arithmetic. The mathematical structure of a Bach fugue is much more complicated and rewarding to attention. Mathematics really is a universal language. So we did make sure that the record included music that would reward mathematical study.
I have concerns. I mean, we have intelligent life on our own planet, dolphins and whales, that we don't communicate with. We cannot communicate with, other than tricks for fish. And it's a little conceited to think that, it's going to be like Star Trek, and if we find some advanced life that will immediately sit down for tea together or something, it's not going to be that simple.
So the Voyager record has a set of pictures on it that depicts our civilization, but we only had the ability to do about 100 pictures. That was as much data as we could send. So that was kind of hard.
It was a process of distillation. You can't describe the Earth in 100 pictures. You can't describe the Earth in 1,000 pictures. But what art is about is taking something that's small but can represent the whole.
We thought it was very important to pick some pictures of humans nude on the record to show just what our anatomy was really like. NASA had been seriously criticized about the Pioneer plaque. There were actually letters to the editor in newspapers saying that NASA was sending smut to space. How are we going to show pictures of naked humans without it looking salacious? And the answer to that was, why don't you put a pregnant woman in the picture? Because pregnant women are not considered salacious, not appealing sexually. So that's what we did.
And I figured if this doesn't get past NASA, nothing's getting past NASA. And I guess the answer was nothing's getting past NASA because it was the only picture that they made us take out.
Now it's 5 years of cruising out to Uranus.
Uranus will be the most remote object yet visited by a spacecraft, and it's so remote that it was not even known until 200 years ago. And it's a great distance out there, and if we'd launched directly from Earth, it would have taken 30 years to get there. So we were very fortunate that we could swing by Jupiter and Saturn on our way.
I can only say that as an observational astronomer, I've been trying to figure this thing out for the past 25 years, and it's very frustrating in a telescope to look at that tiny little disk and try to determine anything about it. So for me, the next few days are going to be very exciting.
Once we got beyond Saturn, essentially, the engineers threw out the rule book and said, how are we going to make this work? How are we going to take pictures of planets this far from the sun?
Voyager was the first of a class of NASA spacecraft that could be reprogrammed. They could take what was on the computer and just wipe it away and give it a whole new set of software. They trained the spacecraft to pirouette like a ballet dancer. Basically, you want to take a picture of that thing and it's going past you really fast, so you spin the whole spacecraft and follow it like this. And so even though it was darker at Uranus and really dark at Neptune, you could leave the shutter open without smearing. And that was just beautiful.
We had all of the rich set of goodies from Jupiter and from Saturn, but Uranus was unknown.
Our going on out to Uranus and Neptune, that was the first time. We just had the one spacecraft, so we were more or less just flying blind, and we didn't get a second chance. Nor will there be a second chance, I think, for quite some time. It's very unlikely that we'll all be dead and gone before anyone goes back out to Uranus and Neptune again.
It was like taking something that was almost fictional, almost mythological, and then seeing it as a real object.
The spacecraft flew through that system like a bullseye because Uranus is tilted on its side with this beautiful aquamarine blue methane atmosphere. And all these pictures, every single one of them is like, whoa, and you could hear people just, whoa, and everybody be doing something and somebody would go, whoa, and everybody would turn and look up, oh my gosh, look at that. There was no internet, there was no news stream going out to live CNN. The only way to experience that sensation of being one of only a small group of people who saw a point of light become a world, the only way to experience it was to be in that room.
Well, just about 2 minutes ago, Voyager 2 passed through its closest approach to Uranus.
The new ring is right here. Now, I don't... You're telling me you can't see it. I can.
Dr. Soderblom, as you whizzed through your explanation, I couldn't put it all together. Could you try that again?
Slower?
Slower and a few more details?
I thought that was pretty slow.
Every time we arrived at a new planet, there were always surprises, even though we had gotten a lot smarter. For instance, before Voyager, all the magnetic fields have the magnetic pole near the rotation axis of the planet. And that was true for Jupiter, it was true for Saturn. And then we flew by Uranus, and the pole was near the equator.
There's been a lot of speculation about the magnetosphere of Uranus. Would there be one? What would it be like? And the magnetosphere of Uranus is far more weird and wonderful.
We found the planet's tipped on its side, but the magnetic field is then tipped relative to the spin axis. So you have this huge contortion in the magnetic field as the planet spins around. Just bizarre. Why on earth the magnetic field was so messed up, we had no idea.
At the time the Voyager 2 spacecraft flew by Uranus, one pole of the planet was pointing at the sun. At that point in its orbit, its atmosphere shuts down. So the planet itself didn't look exciting. And part of that is Uranus itself holding its secrets back.
That had to be, I guess, one of the, well, disappointments in that Uranus was not more photogenic than it was. It was actually pretty blah.
Poor Uranus. Poor Uranus.
Uranus itself was not the character that Saturn and Jupiter were. It had very, very subdued features. The big stars of the Uranus encounter were actually the moons.
If you're going to go to Neptune, you still have to use Uranus for gravity assist. The gravity assist aiming point at Uranus just happened to be pretty close to the orbit of Miranda. Now, some of the scientists, Miranda is not the largest moon of Uranus. And if Uranus had been the last stop, the scientists might have wanted to go to a larger moon, which ironically, I don't see how anything could have been any more interesting than Miranda. It looked like a jumbled up mess.
This moon looked like it had been ripped to pieces and then just sort of shoved back together again.
Whoa, come look at this.
Going up to the screen and pointing and saying, did you look at that, look at that.
No, nobody was ready for Miranda.
In parts, there were enormous cliffs and gashes in which fault blocks had dropped down. And one of them, you can see the edge of a cliff that is it's got to be 10 kilometers tall. Now, the gravity on Miranda is so weak that if you jumped off the edge of that cliff, you could read the newspaper on the way down. You probably would fall for 20 minutes. But when you hit the bottom, you'd still be going 100 miles an hour, so it probably wouldn't. It would be the last newspaper you read.
One of the things that we have to remember about Uranus is it was a very sad time for everybody, because we were just about to present all our results. We were all about to have the big final finale press conference. And came back from breakfast and I went to go watch the shuttle being launched.
We have main engine start, 4, 3, 2, 1, and liftoff. Liftoff from the 25th Space Shuttle mission, and it has cleared the tower.
And we thought, okay, great, we'll watch the shuttle launch and then we'll go to the press conference. But of course, that was Challenger.
Engines throttling up, 3 engines now at 104%.
Challenger, go at throttle up.
Challenger, go at throttle up.
People were just like astonished, this gasp, like, oh my, did you see that? Did it really blow up? Because we had stopped in our meeting so everyone could watch it. And then there was just silence, people were crying.
Well, what can you say? You knew right away that a bunch of people were dead.
Flight Fido, go ahead. RSO reports vehicle exploded. Copy.
And then, of course, they showed replays and replays and replays over and over and over again.
We have no downlink. Okay, everybody, stay off the telephones. Make sure you maintain all your data. Start pulling it together.
The Challenger accident happened as we were receding from Uranus. I have this vivid memory of picture after picture of the crescent Uranus coming back and the replay of the Challenger explosion, and it was just devastating.
Today is a day for mourning and remembering. Nancy and I are pained to the core by the tragedy of the shuttle Challenger. We know we share this pain with all of the people of our country. This is truly a national loss. I know it's hard to understand, but sometimes painful things like this happen. It's all part of the process of exploration and discovery. It's all part of taking a chance and expanding man's horizons. The future doesn't belong to the faint-hearted. It belongs to the brave.
Reports from the flight dynamics officer indicate the impact in the water. Approximately 28.64 degrees north, 80.28 degrees west.
During these closest approach time periods, we would have hundreds of reporters come to JPL, and it was a great news atmosphere. And when the Challenger exploded, everybody just left.
It was really a very sad time. Sad ending to another great mission.
Those cosmic questions we hope to learn by sending our machines out, the very same questions that you and I and every child has asked themselves. Where do we come from? Are we alone? What's the universe made of? How will it end? All of these basic questions are the questions that drive science. I do cosmology. I study the beginning and end of the universe, and some people say, what's that good for? And I always say to them, you don't ask what's a Mozart symphony good for, or a Picasso painting. But science somehow seems, in order to be useful for people, it has to produce technology. But the beautiful thing about science is the ideas. From a child, you ask your parents why. But when you grow up, you finally realize that what you really mean is how. Einstein has told us that space and time are tied together integrally. We live in a space-time. If our universe came into being and space popped into existence, then so did time. And so time itself may not have existed literally before the Big Bang, so there was no before. And that seems crazy, because if there's no before, all these ideas of cause and effect, et cetera, go out the window. But all it means is that we'll have to change the way we understand things. Another possibility is that our Big Bang is just one of an infinite number of Big Bangs that are occurring in what we now call a multiverse. It's an amazing change of view, which makes us yet even more insignificant. We were insignificant enough traveling around the sun in the middle of nowhere, around a random galaxy amidst 100 billion galaxies. But now we know that even the whole universe that we call home may just be an insignificant something in the midst of something much bigger. The history of science is to remove us ever further from the center of the universe, if you wish, or the center of the action.
Finally, at Neptune, Voyager has begun the last of a decade's worth of encounters with the outer planets.
It was another 3.5 years to get out to Neptune. They had to reprogram the spacecraft again, teach it some new tricks to work in this even darker environment, even colder environment.
If we take the Earth being 1 astronomical unit from the Sun, or AU for short, Neptune is 30 times that distance.
When we launched Voyager, there was no capability to get any images back from 30 AU. That capability happened all after launch. It involved reprogramming the spacecraft, taking 2 34-meter antennas and adding them to a 70-meter antenna.
Copy, we're ready to run that observation.
It meant using the entire Very Large Array in New Mexico, 27 antennas, to collect the very weak signal that we could get back from 30 AU.
The flybys past Jupiter, Saturn, and Uranus had sped up the spacecraft too, so it's going even faster. So enormous amounts of pressure, and one shot.
There it was, just sitting out on the edge of our solar system, waiting for somebody to come out and appreciate its beauty. Just waiting for the day that humans would get out there and go, wow.
Neptune was photogenic right from the beginning.
I had been taking pictures of Neptune from the ground, where we couldn't see very much. You know, in my head, imagining what it might look like, and seeing that turned into reality. It's a rush. Looking at this blue, bright blue orb. In some ways, it was evocative of the Earth, which seemed very bizarre for the last planet that we were flying by. I was a meticulous log taker, and I would make little notations in these logs, and I would draw little pictures, and you could see, oh, what's this little dark spot? Bright clouds. I'm like, wow, wow, exclamation point, and I'd draw pictures and arrows. The most surprising thing was a giant dark spot. Nobody had any idea that would be there. It's huge. It's like a hole in the planet. So we called it the Great Dark Spot, because we're not very original when it comes to names.
We had to basically make a forecast of the storms on Neptune in order to point the cameras during the last day. And at the same time, there was a hurricane off the east coast of the US, and the weather forecasters were trying to forecast that hurricane. But they were trying to forecast it 12 hours in advance, and they were having a lot of trouble because the storm kept changing position. And we were just calmly plotting points on graph paper and then say, okay, 2 weeks from now, this storm is going to be right here. And it usually was.
At Jupiter, Saturn, and Uranus, the goal was to do a flyby that would take the spacecraft onto the next planet. When it came to Neptune, we knew that that was the last planet that we were going to fly by, and so we could take a different trajectory. This allowed us to get a really spectacular view of the rings and then look back on the system in a way that was quite beautiful.
Think about imaging the rings of Neptune. They have reflectivity which is twice as dark as soot. And the light that's falling on them is 1,000 times fainter than on Earth. So you have 1/1000th the light, and you're trying to image something which is twice as dark as soot against a jet black background.
More than one ring could be seen even in the raw images, that is so-called ring arcs. And it seemed reasonable that this was indeed the lost ark that our imaging team raiders were looking for. Now you're going to turn on me, right?
We knew at Neptune we wanted a close flyby of Triton, which was a huge world in a retrograde orbit around Neptune.
If you looked at them on the way in, they weren't lined up. One's up here and one's down here. And so what are you going to do? Well, there was a way, and the way was to fly over the North Pole, very close to Neptune, to bend the spacecraft so it would go down and then intersect Triton.
But that meant getting to within just a few thousand miles of the cloud tops, which is like skimming the surface. And they had to hit that, you know, exactly right.
There was a lot of concern that we didn't know enough about Neptune's atmosphere to really be sure that the spacecraft would not tumble. It's also possible that there were particles in these ring arcs that we might go through a cloud of shrapnel, and that would be the end of the spacecraft if we did that.
Just a slight error in the calculations, and instead of skimming across the cloud tops, you're skimming into the clouds and the spacecraft burns up. Slight error the other way, you go a little too far, you don't bend enough, maybe you run right into Triton and crash, and that's the end of the mission. You don't have enough time, you have to make your last best guess. Hit the send button. It would have been just fascinating to be hanging onto that spacecraft, right? Skimming over these beautiful blue cloud tops of Neptune. And then as you come over the pole of Neptune, seeing that big moon Triton rise up.
After several billion miles of journey to get us to within a few kilometers of where we need to be, it's just absolutely remarkable. You know, threading an incredible needle.
Southern hemisphere of Triton is entirely covered with nitrogen ice. And as we flew past, there we go again, as we flew past, we were able to look down at what looked at markings on the surface of the polar cap. We were putting together a mosaic of Triton's globe, but we couldn't get things to line up quite right. Some of the dark streaks, two in particular, would not line up.
He's like just scratching his head. It's like, I have no idea what's going on here. This guy's one of the world's experts on anything having to do with planets and moons, and he can't figure this out?
The only crazy idea that's left is eruptions.
I said, well, let's put it in a stereo viewer. Red and blue glasses. And the images fused into a three-dimensional model, and up popped these geysers. And I said, holy moly! And so we knew what we had.
These plumes, black geysers spewing out this stuff.
The plumes extending out of the surface for like kilometers.
We were seeing eruptions on a world which should have been just a frozen cinder. The last place we would have expected to see further dynamics, further eruptions, was at a moon this remote in the solar system.
This is at 37 degrees above absolute zero. So there's solar-driven geysers on a satellite that's 30 astronomical units from the sun. And who would have thought?
Just because an idea is crazy, it's not necessarily wrong.
We knew this was the last planet Voyager would explore before it headed on for the rest of its journey. And so I think the times together as a team, the times to look at the pictures, talk, meet together, became more precious.
I was passing by the secretary's desk, and she said, "Oh, Candy, there's a reporter that wants to talk to you." And he said, "The countdown clock just went from minus, counting down, to counting up. Your Voyager's now leaving Neptune." And he said, "How does that make you feel?" And in that moment, I dissolved into tears.
After the spacecraft went past and turned around and looked back, and this beautiful crescent, Neptune and Triton, and people realized that's the end of the planetary part of Voyager. That's the last port of call. The last thing that we'll see in our solar system is now behind us. And it went from the Voyager planetary mission to the Voyager interstellar mission.
Of all the images, that was one of the most poignant because it was our goodbye or farewell image.
We could have enhanced the color a bit to make a somewhat prettier picture, but out of respect to the Voyager spacecraft, we decided to show it to you just as it is. So this was Voyager's farewell to us, and it's our farewell to you.
The way I looked at it was, gee, we did something really great. Very, very successful mission.
A little weepy. I mean, there was a lot of energy put into this mission.
We have a mission, and we have liftoff.
Years of intense effort. It was the end of a sentimental journey.
We did it. We pulled it off. And that's important. It is.
We had a big party at JPL, so that was a good send-off for Voyager.
With a little sarcasm, I'll say that JPL's greatest moment was when Chuck Berry was on the steps of our administrative building doing the duck walk to Johnny Be Good.
Chuck Berry, he was present at the Neptune Encounter celebration, singing Johnny Be Good.
Star of the party, Chuck Berry, came out from behind the wall of Building 180 and played Johnny Be Good live. Everybody started dancing, and it was fabulous.
Ed Stone was dancing to Johnny Be Good. It was something to see. Everybody was dancing.
Rock star moment, and sail on Voyager.
I'm going to go get some sleep, or maybe I'll do a little more dancing. Thank you very much. Luke?
Meanwhile, Voyager 1 is still kind of cruising out there, getting farther and farther out. And a number of folks on the team, including Carl Sagan, had this idea that before we have to shut the cameras down, let's turn around, look back towards the sun, and let's take a picture of our solar system, unlike any that had ever been taken before. And there was actually opposition to it.
They just didn't want to do it. They couldn't get their heads around what would be the point of taking a picture of the Earth and Jupiter and so on, because they're just going to be little points of light. So Carl, being Carl, actually went all the way to the NASA administrator and got the NASA administrator to direct the Jet Propulsion Laboratory to take this series of pictures.
Absolutely zero science in it. Absolutely none.
People have been taking selfies of our planet for as long as the space program has been going on. No one had ever taken one like this. They ended up on Valentine's Day, 1990, taking this beautiful family portrait.
When we did our portrait of each of the planets, I was the first person to look at the pictures, and I knew every blemish. And so I could pretty quickly go blemish, blemish, blemish. And I thought, well, where's the Earth? How could we, And then I realized there were a lot of streaks of light in that image. And I realized finally that the Earth was sitting in one of those rays of light. I just sat there for a while, just kind of realizing, wow, that's
that's the Earth. You know, that's Voyager looking back at the Earth. And then once I had sort of recovered, I started calling people. I called Brad. Brad, we got it. Called Carl. Carl, we got it. Called my dad.
And so this is a different kind of milestone than the scientific milestones we've had, one that is really symbolic.
I'm an imaging scientist, so I first realized, oh, this didn't turn out the way we thought it was going to turn out. And my first impulse is to take my hand and wipe away the dust, because there was some dust on it. Well, one of the pieces of dust that I wanted to wipe away was the Earth. But it didn't matter, because in the hands of Carl, he turned it into an allegory on the human condition.
And the next slide. The Earth in a sunbeam. In this color picture, you can see that it is, in fact, less than a pixel. And this is where we live, on a blue dot. On that blue dot. That's where everyone you know and everyone you ever heard of and every human being who ever lived out their lives. I think this perspective underscores our responsibility to preserve and cherish that blue dot, the only home we have.
My father talks about this little tiny speck in this vast cosmic night, and that we're part of something bigger, and we're also, alone. There's a great thing where he says, there's no sign that any help is going to come here to save us from ourselves. It's up to us.
Neptune, the project continued, but it continued in quite a different way. The Voyagers didn't have any more encounters. They were just sailing on out into interstellar space, which people didn't really understand how far that was going to be.
At the time we were designing Voyager, interstellar space, where the boundary was totally unknown. We had our eyes on the interstellar mission. Are we going to push the spacecraft to get out of our solar system and into the galaxy? It was a shot in the dark because nobody knew how far. Uncharted waters.
Goldstone, Voyager Ace.
Voyager Ace, Goldstone.
Please turn command modulation on at 1800.
Goldstone copies 1800 for command line.
That is affirmed.
The sun has this gravitational influence that goes way out, almost halfway to the nearest star. So in terms of gravity, the edge of the solar system, it's going to take Voyager tens of thousands of years to get there. But the magnetic field of the sun can only extend so far. It's a bubble around our star. All the stars have bubbles. We can see the bubbles around other stars out there. So we know that they have bubbles. Where's our bubble end? Where's the influence of the sun and its magnetic field give way to the galaxy?
We kept going, and years went by, and we don't detect the interstellar media.
Throughout the 1990s, still didn't find the edge of the bubble. Throughout the 2000s, still didn't find the edge of the bubble. And then finally, in 2012, Voyager 1, which is going the fastest, which is the farthest, started to see these funny things happen to the squiggly lines. Did the magnetic field of the sun change direction, changed the kinds of particles it was trapping dramatically, and they see this crazy spike. Everybody goes, oh, is that it? And then it goes back to normal. And then it was just literally one magical day it was in August of 2012 that everything changed. And it was like, it just popped out of the bubble. Voyager 1 has left our solar system. It's the first thing built by humans that has left our solar system, and now it's in interstellar space.
Major historic announcement by NASA just a short time ago confirming the Voyager spacecraft. Voyager, as in the thing that launched way back in 1977, exploring the moons, exploring the planets. Well, it has entered interstellar space.
NASA says that Voyager 1 has become the first man-made object to reach interstellar space, the cold, dark region between stars.
And we've slipped the outermost grasp of our solar system with Voyager 1, the first human-made object to venture into interstellar space.
It's a wonderful achievement, actually, when you think about it. It's historic. It's our first step out of our bubble, which has been around all the planets and around the Earth essentially forever. Now, finally, some little thing that we have built has left that bubble and is in the space between the stars.
I loved it when that happened. It was like humanity has arrived in interstellar space, and we all feel like Voyager has carried a bit of us into the galaxy.
It is the little engine that could. It's the little spacecraft that keeps on going and going and going, and nobody really knows how it does it, but everybody's rooting for it.
There's never going to be another mission like it. It was the first and last of its own kind.
Voyager is rarely out of my thoughts. Always some little part of me is wondering, where is Voyager tonight? Whenever I look up at the night stars, I look in the direction that each of them is going.
We're the generation that sent something out into space that's not only going to outlive us, it's going to outlive our star. 4 billion years from now, when our sun turns into a red giant, Voyager is still going to be trucking out there through the stars, and the songs of our time are going to be out there. Chuck Berry is still out there, will still be out there.
When the Voyager's power sources go dead, and when the spacecraft can no longer send back any useful information, that's really the point at which the golden record becomes the primary function of those missions, that when everything else is turned off, those records are still floating somewhere in interstellar space, completing the last part of the mission.
I think that the spacecraft itself is the message, the technology of the spacecraft, the radioisotope power system, the communication system, the instruments, all of those things are carrying a message that says the people who built this knew what they were doing.
Is the universe any different, or our solar system today, than it was then? No. But are we different? Absolutely. The thrill of the discoveries, reaching the heliopause, completing the grand tour. I mean, man, our child just made it.
Voyager 1 and Voyager 2 will be orbiting the center of the Milky Way galaxy with all the stars, and every 250 million years it will complete an orbit around the center of the Milky Way galaxy.
There's no wind, water, rain, weathering. There's no planets they're going to run into. There's no asteroid belts or comets that they're going to run into. And over thousands, millions, billions of years, they're predicted to remain pretty intact.
From Voyager's standpoint, the sun is just the brightest star in the sky, not by very much. Years to come, it'll fade into being just one of all the other stars in the galaxy. And from time to time over the eons, a star will sort of approach and get brighter, and then it'll get dimmer again. It's like being in a lifeboat on the Atlantic at night. Maybe you see a distant ship pass, maybe you don't. That's the future of Voyager for billions of years to come.
All of the human tragedies and the worries and concerns that drive you and I and everyone will be long forgotten. And our existence as a species and the greatest triumphs, the things that people think of are the most important things in their life, all of that's going to be forgotten. And the universe doesn't care about it. But it's possible that at least one thing we've created will be out there, and who knows, maybe someday, with an infinitesimally small chance, another being might find it and at least know of our existence. It's highly unlikely, but it's not impossible. And that small possibility surely gives us hope.
We will continue to get signals back from Voyager, and we will continue to try and get signals back from Voyager as long as we can. There will be a day when the antennas are listening to Voyager and we don't hear anything. And that will be the day that we stop communications with Voyager. And that will be very sad, because whether it's 45 years or 55 years or 50 years from when we launched it, it'll be very, very sad. Because it will have gone silent. And we really won't have a chance to say goodbye.
If an alien was to hear my voice, and I would know that he heard my voice, he or she or it heard my voice, I would cheer. I would be jumping up and down with ecstatic.
What did you say? How?
Her.
I
called her a her.
I see that. I wouldn't do that. That's popular nowadays. But I personally do not like to anthropomorphize spacecraft. They don't like it.
Okay, now I've always wanted to do this. Are you ready? 23, tape 7.
Voyager. Wonderful.
I saw a day where we all